Okay, 732, and we're given this diagram here with kind of this link attached to B, which is going to the ground at C. We know that this is a two-force member, so the force at B must be directly in line with B to C here. And what we're looking to find is the internal normal force, internal shear force, and internal moment at point D here. Okay, so to start this problem out, I've drawn the free body diagram here. It's pinned at A, right? We have AY, AX, and then we have FBC acting in this direction, and it is acting, it's a 3, 4, 5 triangle here, and then we have 6 kilonewtons at the top. Okay, so I'm going to do some of my analysis up here so we can see the diagram as we go through this. I'm going to first take the moments, take the moments around point C. So C is way out here, and we can take the moments around any point that we wish. So I'm going to choose C, and you'll see why in a second here. And call counterclockwise positive. Okay, so taking the moments around C, we know that FBC is pointed directly at C, so it's going to contribute nothing to the moment equation about C. So that kind of allows us to take out this equation, or this component of the equation in the moments, as well as AX. AX is pointed directly at C, or the opposite direction of C, and it's going to have no moment contribution around C. So what do we have? We have 6 kilonewtons, which is going to create a clockwise moment, and the distance it is away from C, the perpendicular distance, is 3 plus 1 plus 3, that's 4 plus 3, that's 7. Okay, and then we have AY as well. So we have AY, and that's going to create a counterclockwise moment, which will be positive. And the distance that is acting away, I believe, is 3 meters here, 3 meters. And we set that equal to 0. We can solve directly for AY, and AY comes out to 14 kilonewtons. Okay, now let's take the sum of the forces in the y direction and set those equal to 0. So we have AY pointed up. We have a component of FBC, all right, so, and that would be downwards. So we have FBC as a negative, and then the component of that, the vertical here is 4, and we divide that by the hypotenuse, which is 5. Okay, and what else do we have? Nothing else. So we know AY already is 14 kilonewtons, so we have FBC comes out to be, let's see, where do I have that written? 17.5 kilonewtons. 17.5 kilonewtons. Okay, and now we can sum the forces in the x direction and set those equal to 0. We have the positive 6. We have a component of FBC, and that's going to be in the negative x direction, FBC, and the horizontal is 3, and the hypotenuse is 5 there. And then we have AX. Set that equal to 0. And AX then comes out to be 4.5 kilonewtons. Okay, so now we have the support reactions and the force FBC. We can now talk about solving for the internal normal force, shear force, and moment at D. So what we're going to do is just draw the bottom of that member. And this is point D here. Then we have our AY, and we know that is, we just solved for that, AY is 14. And then we have AX, and we just solved for that, that's 4.5. Okay, and what we're looking for is the normal at D and the shear, and then lastly the moment. So we can draw the moment this direction, the moment at D. So all these internal components here at point D. Okay, so if we sum the forces in the y direction, first off, so sum the forces, we have ND pointed upwards, and we also have AY, which is 14 kilonewtons pointing upwards. And set that equal to 0, we have ND comes out to be negative 14 kilonewtons. Okay, sum the forces in the x direction now, set those equal to 0. We have positive 4.5 at AX down here, and then we have plus the internal shear at D. And set those equal to 0. We have VD is equal to negative 4.5 kilonewtons. Then lastly, taking the moments around D. So sum of the moments around D, set those equal to 0. And we'll call counterclockwise positive here. All right, so what forces create moments around D? VD is actually going right through D, so that will not contribute. ND is right at D, that will not contribute. And the 14 is also going right through D, so that will have no contribution to the moment as well. So we just need to take into account this 4.5, so the 4.5. And looking back at our diagram up here, that is 3 meters away. So that's 3 meters. And then we also have our moment at D and set that equal to 0. And then we come out with the moment at D is negative 13.5 kilonewton meters. So these are our answers for problem 732.